Hello, I am Padma Mallikarjunan. I'm an Enterprise Support Manager at AWS and I am based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Rob Higuereta and Tanya Pauja from AWS Support. Can you give us a quick introduction, Rob and Tanya?
Hi, yes. My name is Rob Higuereta, and I'm an enterprise support lead located in Austin, Texas. Happy to be here today for another episode of AWS Supports You. And really happy to be talking about security, one of my passions here. So, thanks.
Thanks, Rob and Padma. Hi, everyone. This is Tanya Pahuja. I'm a technical account manager here at AWS. I'm located in Delhi, India. I'm working with customers here and across the globe, helping and supporting them on different suites of AWS services. I'm really excited and happy to be a part of this show today. Thank you.
Thank you for joining us from across time zones. Everyone, today we will be introducing to you some of the best practices for securing your AWS Identity and Access Management, or IAM, access keys. We will specifically focus on ways to avoid embedding IAM access keys in your code. We will then discuss about responding to an inadvertent key exposure, either manually or automatically. Before we begin, a quick note to our attendees online. Please feel free to use the chat window on the right-hand side of your screen to ask your questions and share your thoughts throughout the episode. We look forward to hearing from you. Tanya, can you walk us through what we're going to be talking about today?
Sure. Thanks, Padma. So the agenda looks like we are going to do a quick recap on our IAM access keys, and then we'll look into what to avoid with the IAM access keys, certain best practices and recommendations from AWS. We're also going to discuss how to keep the IAM access keys secure and prevent any inadvertent exposure, as Padma just mentioned. And then some of the immediate steps in case of inadvertent exposure of IAM access keys, what are key steps to take care of. In this slide, IAM users and access keys. So if you are new to AWS Identity and Access Management, we're just going to see what all it constitutes of. In IAM, we have IAM users, we have roles, we have groups. Today, we are going to discuss a component of IAM users, their access key and secret access key. We want to avoid leveraging long-lived credentials typically, and so it is very important to avoid using access keys from IAM users. If you can, you should leverage an IAM role, or even better to leverage something like AWS SSO service to authenticate your users. But for programmatic access, many a times our customers ask us when they need to give credentials to their EC2 instances or certain third parties that they have. So today, we will discuss things to avoid if you have to use IAM access keys and what other options do we have in AWS. Here, things to avoid when using IAM access keys. So we want to avoid few things with IAM access keys. One of them is embedding them in your application. Do not embed the access keys and secret access keys in your code. You can leverage other features of IAM to give your application access to services like S3, Athena, or EMR. This way, users don't embed the access keys into their applications, which can add risk to them being exposed or even shared within the organization. The next recommendation is do not share the access keys and the secret access keys between the users in your AWS accounts. So let's say if user shares the access keys, you may lose track of where an access is used, and this can cause a problem for you when you change an access keys. Instead, we can look at using IAM roles assigned to the EC2 instances itself, which we have covered in our previous episode. We will share a link to that episode in chat so that you can check it out later as well for yourself. Avoid using hard-coded IAM access keys with programmatic credential access. So what to do in that case? If you have a need to pass to credentials in your application, we recommend our customers to make use of AWS Secrets Manager. AWS Secrets Manager is a service that allows you to easily manage the rotation of your credentials in your environment, and thus easily rotatable, manageable, and retrieve the databases or other credentials for your application without embedding them in your application itself. Thus, it also eliminates the need to hardcode the sensitive information in plain text. Users and applications retrieve secrets with a call to Secrets Manager's API. So what happens in AWS Secrets Managers? Users instead make calls to the AWS Secret Manager's API to their application and get back the secrets they need to authenticate. And thus, AWS Secret Managers will also help you identify who has accessed the secret so that you can audit where the credentials are in use for your environment. It also makes it easy to manage those secrets via IAM. I'll take a pause here just to check, Padma, do we have any questions from our audience here?
Thank you, Tanya. No questions from the audience yet. Everyone, please feel free to ask your questions on the chat window. We have our experts, Rob and Tanya, here to answer your questions on this topic. Tanya, I do have a question for you. You mentioned SSO or single sign-on. What should SSO users be aware of when using the IAM access keys?
I can actually take that one, Tanya, for you.
Sure.
So some things to be kind of aware of and just cautious with SSO, great service that we offer that lets you have temporary credentials that are mapped essentially to an IAM role that exists in the account instead of having to use an actual IAM user. This is really great for allowing you access into the environment, but because the fact that it's tied to an actual role, the credentials are going to be shorter term, which is what we want you to be able to use. But you're going to have to keep that in mind as you're using like the AWS CLI with SSO or something. They're going to be short-term access credentials that you're going to get from the console there and be able to use. But it's not going to be great for like your programmatic access. And that's why we kind of covered a little bit more of like what Tanya was mentioning on Secrets Manager and such.
Got it.
Back to you.
Back to you.
Thanks, Padma. Thanks, Rob. Okay, so in the next one, let's see what if you're using the AWS Secrets Manager, what does it look like in your application? So here we illustrate what you see on the slide. We have two users who are accessing an application which is running on EC2 instances. They might visit a website that runs and that website needs the access or trying to retrieve the files which we have stored in S3 bucket. Through this configurations, the users access that website and the EC2 instances make a call to AWS Secrets Manager. Now, since the IAM role assigned to instances has access to that secret in your Secrets Manager, it gets back that secret it needs and grants the application running on EC2 to be able to port, retrieve, or get that data or any object that is stored in S3. We covered a similar setup leveraging just an IAM role in the past episode that we have shared, but this is another option for you to give your application access without embedding the credentials in your application. I'll hand it over to Rob. Rob, would you like to take us what if you're already using the IAM access keys in our application?
Yeah, thanks, Tanya. So yeah, if you're already using access keys embedded into your application, you're not alone. If you've been working with AWS for a long time, it's kind of a common practice to be able to embed your access keys and your secret access keys into your application. So what we're trying to get here is to move away from doing so and leverage some newer features like roles in Secrets Manager and such in order to be able to do that. We understand that there's still going to be some use cases where you're going to have to, say, with third-party vendors and such, in which case, even using those with Secrets Manager and these other tools are going to give you some good options. So we're going to go over a few of them here. The first one's Amazon Macie. So with Macie, it's our machine learning, data security, and privacy offering that we have as a service. And it has a built-in managed identifier for AWS credentials. And really what this does is Macie will scan your objects in S3 for credentials that match your AWS access key and secret access key and help you to find those that you can work to kind of, enable that developer to find another method to be able to get the access that they need to their application. Say you want to prevent those from actually being used or committed into your code, That's where the second option comes in with AWS Labs and our Git Secrets offering that we have there. So this is a lab offering that will allow you to deploy into your developer's desktop, essentially a workflow that as they go to deploy code to say a Git repo, it will check it to see if it matches a pattern of, hey, this is an access key and secret access key, or other credentials that you can prevent them from actually being committed in the code moving forward. This is also really helpful to try and prevent accidental exposure of your access key, say by publishing it to a public Git repo. If you do have these, again, in your environment, option number 3, using AWS Trusted Advisor will help you check not only for exposed access keys, but also for aged access keys. And so there's a couple different options there. One, if you do have an inadvertent exposure, you may notice that you'll get an AWS risk flag check that says, this has been exposed. It'll give you the Git repo that you have accidentally exposed it to from your end, and allow you to help kind of clean up that and know that you need to rotate that key. We'll talk a little bit more about what we have to do there as well. And then, of course, with the Trusted Advisor check for just aged keys, you could use that to help you identify ones that are older than our recommended rotation of 90 days. Say you have some 2-year ones out there that you want to prioritize, getting those rotated faster. Our fourth option, we also have AWS Config, and that's going to help you because it has a little conformance rule that's called access keys rotated. And again, it's going to be able to allow you to help identify keys that have been out there for 90 days or longer, so that you can try and set up some remediation rules to kind of go through that. We'll share a link as well. There is a way to kind of do some AWS Config automated remediations there that will help you to kind of set up a workflow to how you're going to handle and interject, those access keys that are sitting out there. So we have a lot of different options that are out there to kind of help you, enable you really to drive your security. But we're going to talk a little bit, and I'm going to pass it back to Tanya about how to respond, in case you have an inadvertent access key.
Sure. Thanks, Rob. So let's discuss about responding to inadvertent exposure to the access key or the secret access key. So in this slide, we are going to discuss what to do if your IAM access keys are exposed. So if you do inadvertently exposed a key and got a notification from AWS, or you yourself notice any unusual activities which is happening in your accounts, there are some steps you're going to want to take. We are going to share the link on this slide in chat, so you can also read it later. But let us collectively go through quick steps to look into that in case of any IAM access keys are exposed. Also, please note for our enterprise support customers, don't forget to reach out to your AWS technical account managers if you need assistance with what to do as well. It's one of the benefits of having the enterprise support. Now let's talk about what are some of these steps. So first and foremost, though, if you get this notification, disable the access keys that you have. Disable them ASAP because you want to log whomever who has access to your accounts as fast as you can. This will also help you stop them from making changes and adding any new resources in your account. We will show you in the demo that we have coming up where Rob would talk about more how to add an inline policy, or like the one which is showed here on this slide, to invalidate the sessions for our users. The next step is read the notification that you received from AWS fully. Read the personal health dashboards entry or AWS support case notification because it contains the information to help. What you should look into, such as searching in Cost Explorer for any of the anomalous spend. Last but not the least, thoroughly review your AWS CloudTrail logs for your account to see what the key has done recently. So you are going to do full audit of everything that the key has done recently to see if any changes have happened in your account. The impact may be small. So we have seen if the access key just have access to AWS S3 buckets, but even that could impact you if there's any sensitive data being stored in your S3 bucket. So any intruder starts making an incredibly large number of API calls to your bucket, and that might lead to increase of spend of your AWS resources. So in our upcoming slides, we are going to show you the first demo, what steps you can take to block the access, and then investigate further what needs to be happening to your accounts. I'll hand it over back to Rob to take it to your demo.
Thanks, Tanya. Appreciate that. And so before I go into the demo, Padma, I'm just going to check to see if we have any questions before we get rolling here into the next bit.
Thank you, Rob. Yes, we do have a couple of questions on the chat window. The first question, thank you for your question, Pro Wells, and also a very similar question from Ramon 357. Thank you for your questions. So the question is one of the solutions you discussed about using it in an application. How would this work? How would auto rotation work with a lot of third-party secrets stored in the AWS Secrets Manager?
Yeah, so I can take that one. It's really going to depend on your vendor as well that you're working with, right? Because if they don't support, which is kind of part of the reason why some people will have to use longer lived credentials, is because a third-party vendor doesn't support doing things with auto rotation, because since that's within your account and not their account, if you don't get them the actual access keys and such back in, it's going to cause some interruption for you. So you really have to plan for that and work with them on it. So it's really going to kind of depend situationally on how it's going to work out for you overall.
Thank you, Rob. The next question is from Lou Fox, Amsterdam. Thank you for your question. The question is, can I use Amazon Macie to find my credentials across all my S3 buckets across organization? I did share a link to leverage Macie to detect secret keys access. But Rob, anything else you want to share on that topic?
So Macie does have integration with our AWS organizations. So that's one thing you can leverage it for as well. So some of our other security offerings also have organization support. And if you're not familiar with AWS organizations, real quickly for those that maybe haven't, say you have a main account and you have a whole bunch of additional developer accounts for various environments that you have and workloads, we can really allow you to be able to manage those much easier with AWS organizations. And so nicely things like, config that I briefly mentioned before, and Macie and Security Hub and some other security offerings we have all integrate with it, so that you can make it much easier for you to manage and not have to, run through each individual account.
Thanks, Rob. And everyone, keep your questions coming. We have our experts, Rob and Tanya, here to answer those for you on this topic. With that, back to you, Rob.
Thanks. So I'm going to share my screen here, and we're going to go through a little demo. If you accidentally, expose an access key to a public Git repo, let's say, you might get a notification from AWS Support. And what you're going to want to do is those steps that Tanya mentioned is to run through these things and make sure that you look through your account. So say you get this notification for exposed user in your AWS account that says, this has been exposed, go clean this up. So there's a few things you're going to want to do. One of them is looking at the policy that's attached, looking underneath the security credentials. And as we mentioned, the first thing you're really going to want to do is deactivate that. Go ahead and make sure that that access key can no longer be used or potentially be shared continuously online with access into your account. So you see here, really easy to quickly go in and deactivate this. One thing I will call out is as you come in to deactivate this, you also have to think about how it's going to impact your application that's potentially using it. If it's a user that just has programmatic access into their AWS account to use the CLI and do their work, probably not as impactful. If it was because you had an access key embedded into an application that you were using, it's probably going to take you just a little bit more time to make sure that you get things back up and running. But definitely want to make sure that you get those deactivated first. So we've gone ahead and deactivated that. We've taken a look at the permissions and see that we have administrator access. And on the slides that Tanya showed, we have an invalidate temporary credentials policy that you can add to this user. And it had a little line in it for a condition, which is basically to, if the token was issued before a certain time, to expire those. So I'm going to add this inline policy here and just copy that JSON that we had into this little area here. That's our policy editor. And we can see that I have it set so that token issue time is 5/17 past this time. And that just basically means that anything that was issued before this is going to become invalidated so that they don't have a session token that they can continue to use. So once we set this, we can review the policy, give it a little name, just so we know what it's actually there for. And we can see that, I'm just going to deny all today. We can see that the request condition has a tied into here. So for our permissions to have access analyzer, full access, all resources, it's going to make sure that it has that token issue time to go with it. So we'll scroll all the way back down here and apply this policy to this user and click create policy. And now we've added this deny all today. There's also an AWS managed rule or policy that we have out there as well that you could add to the account. This would just kind of double up onto what you're doing for blocks, but it's just called AWS deny all. And you can add this, and so we'll add it because we'll doubly lock down our account that we've got here at this exposed key. And we can see overall, now that we've added a deny statement to this, it's a blanket deny to all policy or all actions within your AWS console. So that way this user, if they're currently accessing anything, they're just kind of stopped from being able to proceed with, say, spinning up EC2 instances. So once we've got that, we can come back into our overall access advisor. And we can see that since we've attached these policies, even though we have an administrator access role or policy attached to this user doesn't have any service permissions, right? And that's intentional because we wanted to make sure that we lock out whoever may potentially have access as we start to do our investigation here into, what may have been done by this access key since it was accidentally or inadvertently exposed. Especially since this one had administrator access, we can see that policy and the overall summary here as it loads was to allow everything. So you're going to want to audit as much as you can in this account because you definitely want to make sure that the user didn't, have admin access and kind of clean them up themselves too. So now that we've blocked their access, we want to go look and see what that access key has actually done recently in the AWS account so that you can look to see for things that were created or launched instances so that you can, make sure that you're not paying for something that you don't want to have running in your account. So if we refresh that, we see we have a username here of exposed user, which is the user that was exposed in our account because we accidentally committed, some code to a public repo. We can see kind of some of the actions that this access key tried to do within the account. We have a put role policy, describe instances, we have list roles, we have some resource types that it interacted with. We can see we have 5 run instance commands that were done here. And as I mentioned, we're going to really want to audit each one of these items to see what they did. So we're going to come in and take a look at this put role policy and see that we have a malformed policy document exception, which means we actually have an error when we applied this policy or when somebody tried to actually apply a policy to this role. So luckily it means it didn't really succeed. What they were trying to do is modify this sysadmin role that I have out here. And that sysadmin role, if we take a look at it, has administrator access as well. So they were trying to give themselves essentially, another way to get into the account. They may have modified the trust relationship on this. But just because it says error, like I said, we definitely want to go through and still actually check this out and see, what may be potentially modified. We want to check to make sure that the trust relationship hasn't been changed. They didn't add any additional conditions or anything like that to the account. Because they did have admin access, you really just want to trust but verify as always, just to make sure that nothing, was inadvertently missed on your side when you're trying to clean up things. So we've looked to see what they tried to modify as far as that role and that it had an error there. I'm going to go back and see what else they tried to do. We can see they tried to run an instance. No error code here on this one, so it looks like this was a successful launch of an EC2 instance in our account. And we can see all the different information that it was an exposed user, this access key, and we can see all the information that basically ran across for this account for it to launch. So we can see that, this access key did a run instance in US East 1. Source IP address that we kind of have blurred today, you could use that to identify if your access was from an actual person on your corporate network, or if it was outside your corporate network, or say from your VPN. And that might just help you validate, was this just coincidental that a machine launched at the same time, or was it someone external to our organization actually, doing something in our account? So you can use that information. You can see the user agent. It was run from the AWS CLI. On a Windows machine, right? So you can see kind of some of the interesting information about that to help you kind of continue to audit if this was actual legitimate usage from one of your developers or if it's someone outside of your organization doing that. You can see they launched a T4G large. We come in here and we saw 5 run instance commands, right? And so we see we have 5 running instances. This account usually doesn't have EC2 instances running in it. It's used for some other services. So we know based on some of our checks that we did in the audits that we actually don't need these. You could stop them if you wanted to and change different things, but we're actually just going to go and terminate these instances because we don't really want to pay for them if we're not actually using them. And we're going to go back and see that was the main things that they did overall in this account was try to list roles, put a policy, run a few instances, and see some different things that they did. You can change the timeline in what you're investigating, and that's something you're definitely going to want to make sure that you adjust. Just because you got the notification today for an exposed access key didn't mean you didn't publish it like yesterday. So you definitely want to do your due diligence to go back and take a look throughout things and make sure that you fully audit all of this stuff, like these list roles and put policies and just describe instances, really to verify everything that you have going. Tanya also mentioned that you're going to want to check Cost Explorer. It's going to be a good indicator to help you identify if there's anomalous spend in your account. And so as we can see here in my previous months, like I said, we don't usually have EC2 running in this account. So for November, December, January, all the way up until April, all of a sudden we have this very large spike in our EC2 instance spend. And so that's going to be another indicator that this is, anomalous behavior for this account and something we want to kind of monitor for. Not that we're going to cover today, but we also have this cost anomaly detection that you see over on the side. You can set that up to kind of monitor anomalous spend in your accounts too and help you identify things. But manually coming into Cost Explorer is going to be a really good way to just kind of check and see, has anything spiked? So over our months, that we have here, we can see that big old spike there that we're going to want to investigate and check into. And then, of course, like I mentioned before, what we're going to want to do is go back to that exposed user key, and we're going to want to make sure that we get some new security credentials set up. Preferably, if you could take the time to switch to using a role or secrets manager to get this information so you don't have to re-embed a new key into your application would be great. But we understand, as you're trying to get things back into production, you may just have to come in and quickly recreate a new access key and use that into your application. So you can go ahead and do that once you've verified you've locked everyone out and you're good to back in and you're ready to go again. So Padma, I'm going to toss it over to you and see if we have any questions from the audience so far on what we showed for the demo today.
Hey, Rob. Thank you. Yes, thank you for the demo. And yes, we do have a question here from Mr. Builder 10. Thank you for your question. So the question is about monitoring the billing for anomalous activity. If the bill was significantly larger than the previous month, do we have any methods or ways in which AWS can notify us automatically, and any best practices you can share about monitoring billing?
Yeah, so definitely you want to set up, we have a few different areas which you can use in order to monitor your overall billing. One of them is with budgets and budget alerts that you can set that up. And you can actually feed some of those alerts to things like AWS Chatbot that you can then have sent to like a Chime room or a Slack channel so that you can get kind of instant notifications when things kind of start to breach what you'd have as a normal spend. And then additionally, that cost anomaly detection that I was mentioning before, you can set up for a service monitor or account monitor. And that way you can kind of monitor your spend overall across your accounts in your organization. So if all of a sudden in 1 month, one decides to start spending a lot that you weren't expecting, it will give you a notification of that. Same thing on the service side. If you have a normal service usage, what cost anomaly detection does is it uses machine learning to build a pattern overall of your normal spend. And when it sees that kind of, big change, it will send you notification of that. So definitely set those up. They're super helpful. My customers love the fact that there's, budget alerts and those cost anomaly detections now to really keep you an eye on your spend.
Thank you. A very, very important question. Thanks for bringing up that question again, Mr. Builder 10. And back to you, Rob.
All right. So we looked at manual, but it would be nice to be able to automate, right, a response to an exposed access key so that if it's something that, you have out there and you want it to be kind of more automated. A lot of us always have a lot on our plate. Your security team is probably not exclusive of that. So we're going to take a look at a solution that we have, and we'll share a link to this. We have a blog about it, plus we have the actual GitHub AWS repo that has for the AWS Health Tools, this solution that you can deploy within your account. And so what it's going to do is it's going to monitor overall, IAM access key pairs and to see if they were publicly exposed. And if it does, it's going to trigger an AWS Health alert that sends a notification to Amazon CloudWatch that this event has been triggered. And then it's going to jump over to this AWS step function that's going to trigger a state machine to help you, look into this. So if you joined us a couple episodes ago, we talked about AWS step functions and how you can use it to modernize your workloads. And this is exactly what we're kind of using here, this step function to orchestrate a few lambdas that are going to help us to secure our account automatically. So we'll see what this works like a little bit more here in the console shortly. But what it's going to do is trigger 3 lambdas for us, and that's going to be one that does a lambda that deletes the exposed access key. We're going to see one that summarizes all the CloudTrail entries that have happened for that access key recently, and then it's going to publish it to a security notification topic in SNS, or a simple notification service, that's going to be able to, say, email your security contacts and be like, hey, there was a key that was exposed. I've deleted this key. Here's its recent actions that you've had, Again, you still want to go through and actually manually monitor and remediate like your access logs and stuff like that through CloudTrail to be able to verify that. So we're going to jump in to show you what it looks like in order to deploy this solution. But I'll pause really quickly here again, Pablo, before we switch into the demo to see if there's any questions one more time.
Thanks, Rob. Yes, there is one more question here. Thank you. This is about expiring keys and policies we can set on how quickly the keys expire. So thank you for your question, Taniwa3. And the question is, can you control the policies and how quickly the keys expire?
So it's up to you to actually rotate those keys, right? So they're going to have a longer lived overall lifetime. If you just leave them, once you create them, they're just there. And so that's what I was mentioning before about having like ones that maybe you accidentally left out there for 2 years and you have it rotated. And so that's why it's really good to set up those AWS config rules or to have a regular routine audit of trusted advisor findings to make sure that if you have 2-year-old keys, you start to build that overall plan and strategy for how you're going to rotate those otherwise.
Got it. Wait.
And I would just like to add on this. So changing the access key is one of a very well-known security best practice that AWS suggests, because it kind of shortens the period an access key is active. So therefore, it also reduces any of the business impact if those keys are compromised. So as Rob just said, it's very well known to keep an eye, to rotate your credentials periodically.
Got it. Great insight. Thank you, Tanya and Rob. Everyone, great questions. Keep them coming. And with that, back to you, Rob and Tanya.
Great, thanks. Yeah, awesome questions coming in today. Appreciate that from the audience. So today we're going to look at this automated solution in order to be able to leverage this in your account. So as I mentioned, we'll post a link to this blog, but how to automate your IT operations using AWS step functions, Amazon CloudWatch events. So like I mentioned, we talked about this a little bit before on a previous episode of the show, but we're going to take a little bit more look into this specific use case for AWS step functions. As we can see here, same diagram that I shared on the slides where we've got the access key, AWS health triggers, and does these different events here to work through kind of automating this. You can see here a little diagram of our state machine that we're going to take a look at and actually test today so that you can see what this looks like as it runs through. But this is our really simple little state machine. It's 3 steps, very small, but we'll be able to see it go from start to delete all the way through this notify security. And it'll show us, if there's any errors going on through doing that in the state machine. See here, we're going to be able to launch this stack. And the nice thing is it comes in, and when you click on that, if you're logged into your AWS account, so it's going to be key, get logged into your AWS account first, and then you can go ahead and click on that, and it'll bring you right to CloudFormation. We have a CloudFormation stack that's going to easily deploy this for you with very little setup on your side in order to do so. So we'll come in here and we'll click through next. We'll give it a name. I already have it pre-deployed as AWS Health Creds Exposed. I'm going to add a number there. Go to next. And we're just going to allow some IAM permissions and stuff for the solution in order for it to work. And we'll click Create Stack. So as I mentioned, I already have it deployed here. So we're just going to take a look at some of the resources that we have deployed. We can see we have a Lambda that's going to delete access key pair. We have a role that we gave that's going to be the permissions for that state machine in order to be able to actually do things within our account, like delete the access key, summarize our CloudTrail findings and such. We've got our exposed key step function that we're going to be using. We'll show you the state machine tied to that here in a little bit. And a few other items that help to make things work. So I mentioned that we've got this little here that's kind of a test step that we're going to use. And I'm going to switch over to our Git repo that we actually have of this because it has some of the steps in order to give you a little more guidance on how to test the solution. Because we do want to delete the exposed IAM key pair. We want to just verify after we launch the solution that it's going to work. So we've taken care of a lot of this in ahead of time, but we have this whole section here in the Git repo that's called testing the example. That way you don't have to wait until, maybe you have an inadvertent exposure to verify this actually works. You can run through this simple test and be able to, get your email notification that will show you as well as to what was done inside of your, account while you tested this. So for me, I already created this user that we're going to have. I just called it test user per the instructions here, gave it an access key with programmatic access. And, we have the step function already deployed. We have this new execution that we're going to do. So I'm going to copy this because all I really need to do is copy that, go over here to my step function, find my state machine that I'm going to be using, which is my exposed key. And then I'm going to go in and I'm going to start an execution. And I'm going to paste in that JSON. And we can see that I have one thing that I need to change, and that's this access key ID here, because otherwise it doesn't know what access key I'm trying to test against. And so as it says, change access key ID here. So I'm going to go to this user, and that's the one that we're going to use. That's my test user. I'm going to go back to my step function here and replace this access key ID here with the actual access key that I want to test. So I don't have to change anything else in this example. When I get my email notification, it's going to be a bogus account number that's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and some other just kind of non-important information. But really what we're doing is working through to test to make sure that the step function triggers, that we get the email summary of our items, then it deletes this key. So I'm going to start my execution here. And when I start my execution, we're going to go back into the step functions, and we'll actually be able to see our state machine here that we saw in the documentation in the blog. And we'll see that we have delete access key pair is in progress. And we should see this change here pretty quickly to everything being succeeded. And you'll see that it'll change to all green here in a few seconds. And that just tells us that from the start of this, it went through and deleted the access key pair, looked up my CloudTrail events, notified my security SNS topic, and went through. If anything failed, we'd have these different items that were down here at the bottom that say like look CloudTrail like failed or caught an error. And we'd actually get that in the summary that says, hey, you had an access doing part of this. So kind of has some error detection built in. Now, if we come back to this IAM user, we can see that the key's here. That's the key that I actually used to test with. And if I go ahead and refresh this, just take a second to load here. We can see if I scroll down, this access key is actually deleted and gone. So it's gone ahead and deleted that access key. It can no longer be used. And you'd have to create a new access key in order to get back into using that specific user. So we've got the test user that we use for the solution. We've got no longer any access key that can be used for that. And what we're still going to want to do, as I mentioned before, is you're still going to want to go through and manually verify some things in CloudTrail. But you will get a notification after this all runs through. Like I mentioned, this last step is notify security. Got rid of everything that we have here. It's something that we're going to want to look through and actually manually remediate if we want to detect anything additional. Now, for the purpose of this demo, I had logged into this user and ran a few run instances, list roles, and describe instances that we see here, just so our email summary actually has some content. And we'll be able to kind of come over and see an example of what that email notification is going to look like. So we'll see here that we have at 2016-06-05, right, an IAM access key for this access key was deleted after it was found to have been publicly exposed on the internet. And then it says below are the summaries of those actions that it took. And we can see the run instances, the list roles, the describe instances that I tried to use the Amazon Linux 2 AMIs with that AMID is for. And those are the resource types that I kind of affected for EC2. So this gives us our summary overall without having to necessarily have somebody automatically log in, or not automatically, but manually log into the AWS console and audit our CloudTrail logs. This is going to send us this summary ahead of time in order to be able, to kind of help our security team stay ahead of things. So I'm going to pause there, Padma, and bring you back in here, see if we have any questions from the audience about our automated solution today.
Thank you, Rob. So far, no questions on the chat window. Everyone, please feel free to add your questions. We have Rob here who can answer those for you. With that, back to you, Rob.
Great, thanks. So that's mainly the content that we had to share today. Overall, we really wanted to focus on the fact that you have other options to be able to use other than your AWS identity access and secret access management keys, whether it be the Secrets Manager or using IAM roles instead to give you access into your resources for programmatic access with your applications. And then we also, in case, like I mentioned, you have third-party vendors and stuff that are going to be requiring those access keys, you can set up some other methods to be able to either automate response or, as we discussed from some great questions that we have the audience on how we work with Secrets Manager to overall, work with our vendors to see if we can't work up some auto rotation and stuff like that with them. Tani, do you have anything you wanted to add today?
Yeah, I think thanks, Rob. You've already covered, but yeah, I think having an established process to secure IAM keys and secret keys, and that is run regularly, also ensures the operational steps around the key rotations are verified. Because we have worked with customers, we have seen changing a key is never a scary step, but any exposure or any inadvertent exposure or intruding, can cause you business impact. So keep sure you're rotating your IAM access keys periodically. And also, one of the audience, the questions was about logging and monitoring. So we do have a lot of AWS services like CloudTrail, AWS budgets, which Rob has already mentioned. You can also utilize cost and usage reports to keep track of your AWS usage to find out, if any anomaly is happening in your account. So there are several tools available to monitor your billing, your cost management, as well as your IAM access keys are secure in place. That's all. Thanks, and back to you, Padma.
Thank you, Rob, and thank you, Tanya. Everyone, today we looked at securing your applications using AWS Identity and Access Management, or IAM, access keys, and we also discussed alternatives for authentication. Thank you to our moderators for posting the registration page for the upcoming episodes, awssupportsyou.splashthat.com. You can also view our past episodes on that page. Please bookmark this page, and we hope you can join us next time. If there are any questions that were not answered today, please post them on forums.aws.amazon.com and email us any feedback. AWS Supports You at amazon.com. We look forward to hearing from you, and tell us what else you would like to see on the show. Thank you for joining us today at AWS Supports You, and happy cloud computing.
Happy computing.
Thank you, everyone.